hi all. Last class I was discussing about ER mapping to table. What I told about the conversion of an ER diagram to table with the following steps, like a conversion of many to one relationship to the table, right? So last class I told about conversion, like first I started with step 1 with a many to one relationship, right? So one to one relationship. So one-to-one relationship I told about a one-to-one relationship I told about, right? So then I told about one-to-many relationship. Then I talked about many-to-many. And I talked about many-to-many with many-to-many relationship that is possible, right? Many-to-many relationship I told about, right? I told about many-to-many, one-to-many, many-to-one, and many-to-one with one-to-many, right? Then I told about weak entity to relationship. Weak entity to relationship. Okay? Weak entity to relationship I told about. I talked about and weak entity to relationship. Okay, weak entity to relationship I told about. Then we discuss about conversion of a ternary relationship. A ternary relationship to the table. Okay, to the table. So I talked about ternary relationship to the table. Then I told about a weak entity to the table, some generalization to the table. I talked about generalizations to the table. Okay, I told generalization to the table, right? So I talked about many to one, I talked about one to one, I talked about one to many, I talked about many to many, I talked about weak entity to relationship, I talked about ternary relationship to the relationship, I talked about generalization to the table, right? So I represent all this one, a representation, what are two things as in a ER table to what you call as ER table to ER mapping, ER diagram to table I have done. Table I have done in last class. So now I'll move to aggregation to the table. I'll move to an aggregation to the table, which is one of the fantastic thing where you want to convert the aggregation that arises in a table. Right? So aggregation to the table. So to the aggregation to the table. So here I'll take one small relationship where student. As I previously in the diagram I told about aggregation, right? I talked about aggregation. I saw one of the fantastic example of an aggregation. So now I'll take a student with a student ID and student name. So student name, I'll take other entity, that is professor. So professor, what? Professor ID and professor name. Professor ID and professor name. Then I'll take courses. Courses with course ID, course name. Course ID, course name. So course ID, course name I kept about. So these three entities I am considered to build an aggregation relationship. Okay. So then I'll go with professors teaches the courses, right? So professor teaches the courses. So professor itself is a professor, is a job of teacher to teach us a courses, right? His job is to teach course. That's what. So professor teaches the courses. right? Student attains. Student attains. Student attains. So student have relationship with professor, student have relationship with course, right? As you know, because as a student, my job is to listen to the courses taught by professors. And also I need to meet professors in the middle, right? In the middle to discuss about subject, to learn about subject, are required to meet professors, right? That's what student attends professors, student attends course also. To learn a course, you require to attend classes, right? That's what I required. Student attends courses with student, what attends courses with professors, right? So I'll make an aggregation of this. I'll make an aggregation of this. I'll make an aggregation of this with like that. So student attends both professors and a courses, both professor and a course. So I'll make a relationship that can be student attains, that aggregation with aggregation of professor and students make a relationship with student, right? As a professor teaches courses, courses and professor both needed by students. That's what I aggregate professor and student to a one, professor and a course to a one student, professor and a course to a one student, okay? So professors teaches course, aggregate that one and made a attends by student. Student required both professor and a course. That's what I made a aggregation like that. That's what I made a aggregation of professor and course for a student, okay? So now my job is to convert this to table. So I have table 1 is student table, that is containing student ID and student name. Student ID and student name. That is the first table that we have. Then I'll go with professor table. So professor table containing PID and P name. Okay, this other table that contains by professor, that's one table. Then I have course. So course as course ID and course name. What? Course table. What? Course table, right? Then I have teachers. So containing other table, that is teachers. So it is containing, so the one is PID with CID. So because teachers take a key from professors and key from course ID and make a new table, that is teachers, okay? So next job, attains is our table that I want to build up. So attains is the table that I want to build up containing following tables. One is from student ID, another one is PID, another one is CID. Okay, that is attains. So totally about 4 tables have been created, right? So 5 tables have been created. One is professor. So individual entities are tables. Okay, individual entities are tables. What relationship? That is teachers with the PID and CID, that is professor PID with the course ID. Then attains what? We recall from key from student ID, that is SID, key from professor, that is PID, and key from course ID, that is key from course table called course ID, and made a relationship with a new table that is attains. Totally 5 tables have been created for aggregation. In generalization, I will talk about super key and sub keys I talked about, which is called child with the parents with the children's. Now aggregations make individual relationship that has been built with the entities, made a beautiful tables. So here you can say that student attains aggregation of professor and course. What tables of individual entities table with relation teacher as a table and attains as a 3 keys taken from 3 entities made a beautiful table. So this is about aggregation to the table. So last class I told about how the steps have been converted. So this is the last step that is come with the aggregation to the table. Okay. So hope it made it to understand, because it's very easy to understand, very easy to build a tables. So when there is a question to ask about explain the IR mapping table, so you want to take a beautiful table of examples. So go on building a diagrams and go on building a tables based on diagrams, Okay. So next one, I'll move to relational model. So now we have a tables have been built by diagrams. Okay, I have seen all the diagrams. I've shown here diagrams. So from here diagrams, we go into built-in tables, right? We have built-in tables. So what is the tables is all about? So first chapter comes with model 1 comes with the introduction. Then there is comes up with what is AR diagram. So AR diagram I built it with showing with AR mapping to tables. Now the chapter starts. Model 2 starts with a relational model. Okay, a relational model. So relational database we call as RDBMS. So what do you call as? Say RDBMS. What do you mean by that? What is relation model? It's a set of rows and columns. It's called a tables. That is called relational model. So RDBMS talks about a table. A relational database talks about set of rows and set of columns that is built for and database. Okay, I'll give a fantastic example how to represent this. So this is the table. What if I consider student? So student is an schema or a table name or a relation name. Okay, a relational name. Okay, so student as USN, student as name, student is age, student as department number. Student maybe department number that belong to. Student is belong to. Okay, so USN is a primary key and name is with the attribute. Age is another type of integer with department number. Okay, so now I'll fill some tables so that it's easy to make you to understand what is relational database. What is relational database? It's nothing but a table. As I told you, a set of rows and columns. Okay, so USN 1, 2, 2, 3, 4. What some names I defines. With name I defines. So 24, 21. Okay. So now I have a table. As I told, relational database is a set of rows and columns with which is called as a table, right? So table, what? This is called as tuples. The values in a database, this is a table that has been built. It's called tuples. This is called tuples. Okay. So this is called what is called attributes. What do we have in the database that has been built? Okay. This is called an attributes. Okay, this is called an attributes. Okay, so this is called a table name that is called relational name. It is called a relational name or a table name that is. It is called relation name or a table name it has. Okay. So student, its relation name, tuples, it has to built in a table. What attributes that define? This is called relational model. The main thing is for each row and column, you want to fill only one value. I cannot put comma SS, comma M. Okay, I cannot put like that. I cannot put two names in a row and column. In each row and column, I can fill only one value. You cannot fill comma two values. You cannot pull multivariate attributes to the relational database. You cannot pull composite attribute to the relational database. There is only one value for each row and column. For each row and column, you want to fill only one value. You cannot fill multivariate attribute or a composite attribute for each row and column. You can fill only one value for each row and column. It is called a relational database. That is called an relational database. So now onwards, what I will write? I write like this: student, right? It's student table. So student table, okay, contains attribute like USN, like name, like age, right? Department number as attribute, and a key as USN, and key as USN, and key as USN. Now onwards, we write like this. Instead of writing entire things, I write student with particular attributes and key have been identified. Okay. So next I have, so if I write like this, so R containing attributes like A1, A2 till AN. So relation name R containing attributes like A1, A2 till n number of attributes. How much relation particular table contain how many attributes, it goes with a representation like this. So R with A1, A2 till an have been defined for representation of a relational model. Representation of a relational model. So here we have some more characteristics that one define. So this is a relational database that contains, it has some beautiful characters to define. So how it can be? So what are the beautiful characteristics you want to define while building a table in a relational model? Okay. So now some characteristics that it provides for a table. Some characteristics provided by what you call as relational database, some relational database. So first thing is you want to worry about ordering of attributes. So ordering of attributes you want to worry. You want to worry about ordering of attributes. Okay. The first characteristics it has. You want to worry about ordering of attributes. So ordering of attributes means, so at an USN, at a name, at an age, at an department number. So why written the first as USN itself? Why can't write a name, right? Why can't write age in the first itself? No, it's depend upon the domain, the requirement of a particular domains. For example, in my college or in the university, if I tell students a database, the first thing you think about USN, because it has a uniqueness property. If I go for account section and tell my name, that is, I am Sharat Kumar, please give my details of mine, what are the fees I need to pay. If I ask admission or account section, they will not give proper details because my name is for confuseness, because Sharat is maybe entire 5 departments. Even consider master degree, maybe a lot of Sharat Kumar available, right? So then I want to tell my USN. I want to talk about my USN as a first. So I tell my USN is a 4 MH like this. So 4 Mysore region, MH college. So department IS or a CS, right? IS or a CS, which department belong to, right? Which year? 18. So 18 CS, 18 IS. Then I will tell about my unique code 017 or 012 or 011 like this, right? So this is my representation of 10 integer for USN to define my uniqueness property, right? That's what USN is defined, first uniqueness property. Next, after telling my USN, I'll tell my name, this is my name, please search it out. So this is my next uniqueness property. We have only 4 attributes. That's what USN, name, my properties, and my which department I belong to, and which department the student is belong to. So this is the domain suits for a college or a university. If I talk about general people means all the peoples. If I go for taluk office or anywhere office, what details I need to provide to get my details? First I need to provide my Aadhaar details, right? So because Aadhaar is uniqueness property given by a Indian government to identify my uniqueness, right? So that's what. So first initially, if I go for general things, I need to give my Aadhaar details. That is a uniqueness property it has. Then I want to give my other details like name, where I am from, address proof, ration card. Then I want to provide my other uniqueness property which supports my more uniqueness where I belong to. which supports more uniqueness that I belong to, right? So that's the beauty of things that you want to provide while ordering, while building a table. Tomorrow you may do, maybe one day you may, some people, because you are software engineers, right? You people are software engineers. So a lot of things, a lot of softwares are coming up to build up, right? Then you want to require, based on requirement, based on analyzation, you want to think about what is the uniqueness property it has. It has, so people has, or a system has, or a domain has, right? So based on that, you want to decide which is the first uniqueness property. You want to write first uniqueness property, then go on building, rating the ordering of, based on the uniqueness property, go on ordering the attributes, go on ordering the attributes, right? That's what we do, that's what we do, right? That's what I built it. If I go for employee, then I would have go to SSN, right? If I go for movie, then I would have built it, first started with building a table with movie ID, right? Then I go for actor. If I go for build actor table, then I talk about actor ID, right? It's uniqueness property first it has, right? That's what I built it. So student, SUSN. If I go for employee, SSN, right? If I general people consider, then I can go for Aadhaar card, then I go for ration card, right? That's the uniqueness property you want to order on, so that it's easy to identify. The processing of table is easy. To understand a table is easy, right? It's make easy to comfortable with the DTBs, right? So ordering of tuples or ordering of attributes, you want to think about while talking about characteristics of a relational database. Characteristics of a relational database. Then ordering of tuples. Ordering of tuples. So ordering of tuples. So if I consider your name, you start from A, right? Start from A, Abhishek, Abhilash, right? Like this it goes. Then there is a Bharat. Like this. This is the way of the names goes. Next C, Chetan, like D, Darshan, right? It goes. You cannot write Z from Y. Or Y is a, like something different. Yatish, I cannot write as Yatish in the first name itself, right? So it is a alphabetical order you are providing, right? In things as alphabetical order you are providing. So this is in a alphabetical, this is in a USN order, right? How it looks if I go for US and start with a 1 to 100. The ordering is entirely look in a systematic way, right? In a systematic way, start from 1 to 100. How beautiful it has, the table look like, if I consider an ordering of USN wise, ordering or alphabetical wise, how it looks, right? So the ordering of tuples must be in systematic way, in a systematic way. If I consider student as a, first I will go with, for your USN consider 4MH, 18, right? 18 IS or 18 CS with 001, next 002, next 003. The ordering will look very comfortable, right? So you want to always enter the table based on the order details, based on the sorting order details. Based on sorting order details, you need to provide information through a table. Searching is easy. If I consider in a systematic way, the searching will be easy. If I consider, oh, 1 will be in the first row, I can tell 50th row, right? How it easy to identify. The way of speaking will be easy to identify in the tables, right? Such a wonderful things as can be built in the tables, okay? So here USN with 1, 1, see, 2, 2, 3, 4, 4. If I write 4, 4 first, the table will not look nice, right? The querying will be easy. Querying will be simple. Is to enter 4, 4, the automatically retrieves, right? But unfortunately, if I enter in a systematic way, the sorting order, it's look beautiful. It's look beautiful, and table structure look well, and referencing a table is easy for us. Okay, that's what ordering of tuples is other characteristics. You want to consider while building a tables. While building a tables, you need to think about ordering of this tuples. Ordering of this tuples need to consider while building a table. Next point, we want to think about meaning of relationship. Meaning of relations. Meaning of relational name. Meaning of a relational name. So meaning of relational name, meaning of a table I am talking about, right? Meaning of a table I am talking about, okay? So here I told student as USN. Student as unique ID property, right? So how the relationship matches with the attributes, matches with the tuples, right? So how meaningful it has. If I tell Salman Khan here, it is possible to build a table here like this? No, it's not possible, right? So it must be beautiful that it is belong to college database. College database as must have table called student. Student must have uniqueness property, that is USN with specified tuples. With specified tuples, right? So like that, that is the meaning, that's the beautification of a database to table, table to attributes, attributes to tuples. Such a wonderful thing, right? Such a wonderful thing. If I go for employee, so employee means factory database or a company database it comes from. Company, employee to SSN, SSN to what I call as tuples. How meaningful it has, how the relationship is meaningful. It's a meaning relationship that has been built, right? So relationship also easy, and understanding of a table is easy, understanding of database is easy for us. Building ER diagram is easy, right? So a relationship must always have meaningful. It must be meaningful relations, name with meaningful specified attributes with meaningful tuples. Okay? So always meaningful relation name. So meaning of relation name must be plays vital role while building a relational database with the tables. So if I consider as one of the things is, so if I go for movie as a database, movie itself an entity or actor as a comes with a movie. So movie as actors, actor as actor ID with specified tuples, So relation must be meaningful. It must be meaningful. Okay, relation, whatever the relation you write in the tables or attributes, it must be related. I cannot put attribute something called which is not related to student, right? It must be related to students. Okay. I cannot put SSN here because nothing to do with the student, right? So student has USN, student has tuples, student has database with the college or university, right? So that's the way the meaning is built. So always build a meaningful table name with the meaningful attributes with the specified tuples, Okay. Then fourth one. So fourth one you need to talk about. Null values. I need to talk about null values. So null values. So really you require null values? Yes. Sometimes some students may not have first year while joining to engineering, they may not have email IDs. That time you need to fill null values. So that table cannot be empty. Which specified each and column and row must not be empty. That time you are required to specify null values. Okay, required to specify null values for what you call as for a relational table or relation table name or relation table that contains. Okay, so always define null values whenever required, when the data is not available. Like some students have joined the BA as a first year course, then they may go with particular row and column will have the null value. Wherever you're not able to find the value of a particular attribute, then you fill null values. Okay, then you can fill and null values. So that's what the null values plays important role while going for characteristics of a relational database. Okay, so this is small introduction to a relational model, to a relational database or a RDBMS or a relational model that has contains. So it is relation name, it has contain relation name, tuples, attributes. Then you want to think about ordering of attributes with the uniqueness property as a first. Then ordering of tuples, again it must be in sorting order. Okay, then meaning of relation, so relation must be meaningful with the database, with the relation name, with the specified attributes. Then tuples comes out with, then null values wherever possible, whenever not able to find, you can fill a null values. If you are not able to leave empty because empty requires a lot of space. So fill null values so that the space will be storage can be avoided, right? Storage can be avoided. So null values can be filled wherever not able to find the values, like student has email ID. Some student may not have email ID, that I can fill null values. Then I can fill null values. Okay. So in the specified, because department number is 3, I specified 3 here. Okay. So these are some of the characters of a relational database. In coming class, I will go with a constants, what do you call as constants, like domain constants, key constants, entity constants we have. That I will go to discuss the beautification of how the constants look like, why the constants are required, why the rules must be applied for particular table. Okay. So relation database plays vital role. It's introduced by code in 1970s. Started with 1970s. It's go on moving. So nowadays we have object-oriented database models, OA, DBMS, what we call as one of the fantastic representation with higher end, where relational database only we can see the drawback of relational database, where you can tell only first normal form it supports, right? So it is want to fill, it does not support composite, it does not support multivariate attributes. To include that, to analyze to work with multivariate attribute or a composite attribute, you require object-oriented database. You require an object-oriented database which talks about C++ or a Java concepts with DBMS, like with overloading or inheritance. Whatever comes with the properties of C++ Java comes with a relational database. Such a way that's been built. So now we move to almost over DBMS. We were working on whatever the things we were working on. So because we moved up the tables, so going after the tables, that movement arises, right? So it has been forwarded such a way. Okay. So that's the relation drawback. So 1970s code as introduced, now it is coming with what is called SQL with all the tables, right? So there's no SQL without tables, so we can build a database, right? Such a way the system and technology has been progressed towards what is achieving a good results. Okay. So this is one of the simple way relational database as a course of B. It's enough for relational database. You can think about relational database with some different way of doing queries with a relational algebra and SQL coming up in a particular model. And also this model required more on what is practical oriented, where you want to do a labs coming up, where we have a DBMS lab, where you want to work on SQL with a relational database. You can think about outright queries. Maybe we started. So you can think about how to write a queries based on the tables have been provided. Okay. So next class I want teaching about constants. So apply this constants to a particular table and go on building a relational algebra. tables. Next I am going to use the tables to build SQL, structured query language, where it talks about DML, DDL. So I built it with a fantastic structure to retrieve a data as early as possible through a tables, provided through indexing. Okay. So thank you so much. Next class I will go with the constant. Thank you.